Hi everybody. In this video we are going to go over cost estimation, and we are going to use a specific method which is called high and low method to calculate the overhead cost that we need to estimate for the upcoming quarters, upcoming months. So what we are looking at here is we suspect that machine hours is the main driver of overhead cost, and we are going to use the high and low method to calculate the variable overhead cost. What that means is, what is the dollar change for every incremental hour change in machine hours? So again, what we are trying to do is, okay, this is kind of our driver, and this is what we are trying to estimate, the overhead cost. So when we say variable, again, what we are really talking about is the slope. And in high and low method, as you see on the graph, what we are doing is we need to graph the machine hours, the thing that is driving the overhead cost. And overhead cost is always on the y-axis, the one that we are trying to estimate. And we plot it based on different months. On high and low method, what we are doing is we are going to take the data point that is far left. In this case, it's March. It's called the low data point. And the one far right. And in this case, it happens to be June. This is our high. So, and this is our low. So we are trying to calculate the slope of this curve. Again, what it's going to give us is, for every single machine hour, what is the incremental dollars that we are trying to estimate in overhead cost. And the rest of this becomes simply mathematics, in the sense that we are trying to calculate the slope of a curve through two points. And what we need to do is take the difference of their quote-unquote y's, overhead costs, divided by the x's, the difference of the x's, and machine hours is this case. In other mathematics terms, machine hours is called the explanatory or independent variable, and this is the dependent variable y. The overhead cost really depends on the number of machine hours you run. So if I do the math, what I'm finding is, for every single machine hour, according to this graph, obviously not all data points will be on the graph, I'm doing an estimation. According to this graph, for every machine hour I will be spending $2. That is going to be my variable cost. Now let's take a look at, this was the slope, let's take a look at the intercept, the one that is going to the line where is going to intersect with the y-axis. That is going to be my quote-unquote monthly fixed overhead cost. So no matter what I do, even if the machine hours is 0, there will be some overhead cost for sure. And in this case, I'm trying to calculate what that is if machine hours is 0. I again have the same 2 points, and I'm going to take either the low point or the high point. It doesn't matter, it's going to give me the same number. And what I'm going to do is, I'm going to say, for example, $2,000, I'm taking the low point here. $2,000 is equal to the slope 2 times x plus the intercept. So what we are essentially calculating is, write the intercept right here. 2000 y is equal to slope multiplied by x plus the intercept. The intercept turns out to be $1,600. So at here, 1,600, this line, which is my estimation curve, intersects with the y-axis. And again, all I'm doing here is pretty much the math on xy axis graph to find the intercept, which is the total monthly fixed cost, at zero activity, and then the slope where for every single machine hour how much the dollar amount the overhead is going to increase. Now I do know that my estimation curve is something like slope times x plus the intercept. So that is my curve, and I know that the slope is 2, the intercept is 1,600. Now I can calculate based on a specific machine hours. If I'm given the machine hours right here, I can calculate the cost estimate. Now I'm going to calculate it for July, and for July the number of machine hours I'm expecting is 1,400. All I need to do is, okay, for each hour I'm spending $2, plus I'm spending a fixed cost. 2 times the x, which is 1,400, plus the fixed cost that I calculated, is going to give me the estimate for July. This is one of the methods. There are different methods to calculate, but what we used in this example is high and low method to calculate the overhead cost that we need to estimate for upcoming months, and specifically for July. And we said machine hours is the main driver, and for 1,400 machine hours, what is the expected cost? And based on this curve, what I'm saying is, okay, at 1,400, this is going to be most likely 4,400. That is what the curve is estimating. If you look at the curve right here, it's literally this data point.